the sound reached them before the shells did. It was the morning of November 19th, 1944, and Corporal Thomas Hendricks stood in a shallow fighting position carved into the frozen mud east of Metz, France. He heard it clearly through the pre-dawn darkness. That distinctive hollow cough, repeated in rapid succession, thump, 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 German mortars, 5 rounds inbound. He counted without thinking about it, the way a man counts heartbeats when he wakes in the night. The Wehrmacht crews were firing from somewhere beyond the tree line, invisible in the November gloom. Hendricks pressed himself against the forward wall of his foxhole and waited for the impacts. They came seconds later. 5 explosions walked across the American position, each detonation throwing frozen earth and shrapnel through the morning air. Then silence. The kind of silence that follows mortar fire, heavy with the ringing in your ears and the knowledge that more is coming. Hendricks counted seconds. 16, 17, 18. At 23 seconds, he heard them again. Thump, 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 thump. That American infantry had come to know across every battlefield, from North Africa to the Siegfried Line. 15 rounds per minute, sustained, methodical, precise, deadly. But something was different this morning. Behind Hendricks, deeper in the American position, he heard an answering sound. The M1 81mm mortars of his battalion's heavy weapons company were responding. The sound was similar to the German weapons, that same hollow percussion of rounds leaving tubes, but the rhythm was faster. Not dramatically faster, just 3 rounds more per minute. 18 instead of 15. 3 rounds doesn't sound like much. In the arithmetic of industrial warfare, where tens of thousands of shells are fired in major bombardments, where entire divisions hurl metal at each other for days on end, 3 rounds per minute per tube seems almost negligible. But Hendricks, crouched in his foxhole with German steel falling around him, was beginning to understand something that would take months of fighting to fully comprehend. Those 3 rounds mattered. They mattered in ways that had nothing to do with the simple mathematics of projectiles and everything to do with the human beings firing them, enduring them, and making life or death calculations based on them. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. This is the story of how American and German mortar crews discovered that in modern warfare, sustainability matters more than maximum capability. It's about how training systems, design philosophy, and industrial doctrine created weapons that looked nearly identical but performed fundamentally differently under sustained combat conditions. And it's about the moment when soldiers on both sides realized that the side which could maintain pressure longest, not the side which could strike hardest in a single moment, would control the infantry battle. The German 8cm Granatwerfer 34 and the American 81mm M1 were products of the same original design. Both descended from the French Brandt mortar developed in the 1920s. Both used smooth-bore tubes. Both fired fin-stabilized projectiles in high arcs toward enemy positions. Both broke down into 3 main components for transport by infantry. On paper, they were so similar that ammunition from one could sometimes be fired from the other, though with reduced performance. But in the hands of their respective armies, shaped by different training doctrines and employed in different tactical frameworks, these weapons revealed profound differences. Differences that would help determine which army could sustain combat operations longer, hit harder when it mattered, and ultimately prevail in the grinding attrition of the Western European campaign. To understand why the German mortar fired at 15 rounds per minute, you have to understand how the Wehrmacht trained its mortar crews and what the German army expected from these weapons. The Granatwerfer 34 had earned respect from every army that faced it. Allied intelligence reports from North Africa, Italy, and France consistently noted its accuracy. Captured German mortar crews spoke of training regimens that emphasized precision over volume of fire. The weapon itself was beautifully engineered. Rheinmetall Borsig had designed it between 1922 and 1933, a period when German rearmament proceeded despite Treaty of Versailles restrictions. The mortar weighed 62 kilograms fully assembled. Its barrel was 1.143 meters long. It could fire a 3.5 kilogram high-explosive shell to a maximum range of 2,400 meters. 3 propellant charges could be added between the shell's tail fins to extend range, giving crews flexibility in engagement distances. But the Granatwerfer's reputation came less from its engineering than from the men who operated it. German mortar crews were trained to a standard that Allied forces grudgingly admired. A typical Wehrmacht mortar team consisted of 3 to 5 men, though 5 was preferred for sustained operations. The training began with obsessive attention to the weapon's sight system. The Granatwerfer 34 featured a panoramic sight mounted on the traversing mechanism yoke, allowing fine adjustments that other nations' mortars could not match. German crews drilled on this sight until they could make adjustments in darkness, under fire, with frozen fingers. The German training philosophy emphasized accuracy through careful preparation. Crews learned to calculate firing data with near-artillery precision. They practiced range estimation, terrain reading, and meteorological correction. A well-trained German mortar team could place rounds within meters of a target at maximum range, a capability that required time, mathematical calculation, and methodical procedure. This precision came at a cost. German mortar doctrine assumed that carefully aimed fire would be more effective than high-volume bombardment. The training reflected this assumption. Crews learned to take their time, to double-check calculations, to ensure each round counted. 15 rounds per minute was not a limitation of the weapon. It was the result of a training system that prioritized precision over rapidity. At the squad level, German infantry doctrine integrated mortars into a combined arms framework that emphasized quality of fire. A mortar team was expected to support infantry advances with suppressive fire that was accurate enough to allow friendly troops to maneuver close to impact zones. This required careful coordination, precise timing, and the discipline to hold fire when infantry were advancing. The German army had developed this doctrine through 2 decades of professional military study. Their mortar teams represented the pinnacle of interwar European infantry support weapons training. Wehrmacht mortar crews in 1944 were not the same men who had invaded Poland in 1939 or France in 1940. By the time American Prusa forces were fighting through France, German casualties had created gaps in experience and training, but the institutional knowledge remained. New crews were still taught the same methods, still drilled on the same precision techniques, still expected to maintain the same standards. The problem was that the war had changed. The grinding attrition of the Eastern Front, the constant pressure of Allied bombing, and the material exhaustion of Germany's industrial base meant that precision fire doctrine was meeting an enemy with different assumptions. The Americans were not fighting the same kind of war. They were not training their mortar crews the same way, and they were not measuring success by the same standards. The American 81mm M1 mortar came from the same French Brandt design that had inspired the German weapon, but the United States Army took that design in a fundamentally different direction. The M1 was adopted in 1931 after the Army acquired 4 Brandt prototypes. Production began at Watervliet Arsenal and expanded to multiple contractors, including Pullman Standard Car Manufacturing and A.B. Farquhar Company. The weapon weighed 136 pounds fully assembled, slightly lighter than its German counterpart when you accounted for the difference between kilograms and pounds. But weight was not where the real differences emerged. The M1's specifications looked remarkably similar to the Granatwerfer 34 on paper. It had a maximum range of 3,300 yards. It fired both light and heavy high-explosive rounds, smoke rounds, and white phosphorus rounds. It broke down into 3 components for transport. A crew of 7 men was standard, though the weapon could be operated by fewer in emergency. What separated the American mortar from the German was not the hardware. It was the training philosophy and the tactical doctrine that governed its use. American mortar training emphasized sustained rate of fire over pinpoint accuracy. This was not because American crews were less capable of precision. It was because American doctrine viewed mortars differently. Where German training treated the mortar as a precision instrument requiring careful calculation for each shot, American training treated it as a volume weapon, a means of placing large quantities of explosive on target areas quickly. The difference showed in how crews were trained. American mortar teams drilled on speed. They practiced loading sequences until they became automatic muscle memory. The gunner learned to make rapid sight adjustments. The assistant gunner learned to load rounds in a smooth, continuous rhythm. The ammunition bearers learned to keep rounds flowing to the gun position without pause. 18 rounds per minute sustained was the official standard, but well-trained crews could exceed that for short periods. The maximum rate was 30 to 35 rounds per minute, achievable for brief, intense bombardments. These rates were possible because the M1 was designed around a fixed firing pin. Unlike some mortars that required manual triggering, the M1 fired automatically when a round was dropped down the tube. This removed one step from the firing sequence, allowing trained crews to maintain higher sustained rates. The American training system supported this capability through repetitive drill. Mortar crews at training facilities from Fort Benning to Camp Pendleton practiced basic gun drill until the movements became instinctive. Load, fire, load, fire. The rhythm was drilled into crews until they could maintain it under the stress of combat, in darkness, in adverse weather, under enemy fire. The doctrinal reasoning behind this approach was rooted in American tactical assumptions about infantry combat. American commanders expected their mortar teams to suppress enemy positions, not necessarily to destroy them with single precise rounds. Suppression meant keeping enemy soldiers' heads down, disrupting their defensive fire, and creating opportunities for American infantry to maneuver. This required volume of fire more than pinpoint. Accuracy. An area 100 yards by 100 yards saturated with mortar fire would suppress enemy positions regardless of whether each individual round landed within meters of a specific target. The American system also reflected industrial realities. The United States could produce ammunition in quantities that Germany could not match by 1944. American logistics could deliver that ammunition to forward units reliably. American tactical doctrine could therefore afford to expend more rounds to achieve effects that German doctrine attempted to achieve with fewer, more carefully aimed shots. This was not wastefulness. It was the rational application of American industrial and logistical advantages to the tactical problem of infantry support. The difference between 15 and 18 rounds per minute manifested in the physical movements of the crews, the design choices that enabled those movements. A German mortar crew firing the Granatwerfer 34 followed a sequence that emphasized verification at each step. The gunner received firing data from the squad leader, who had calculated it based on observer reports and map coordinates. The gunner adjusted the sight using the traversing handwheel and the cross-leveling handwheel below the elevating mechanism. These adjustments required precision. The panoramic sight mounted on the traversing mechanism yoke allowed fine corrections measured in mils, the angular measurement system used by artillery. Once the sight was set, the assistant gunner prepared the round. German mortar ammunition came with propellant charges that could be added or removed to adjust range. For a maximum range shot, 3 additional powder charges were fitted between the shell's tail fins. This process took seconds, careful seconds. Each charge had to be properly seated. Then, the round was dropped into the smooth-bore barrel. It slid down the tube and struck the fixed firing pin at the base. The propellant ignited. The 3.5 kilogram shell arced toward its target. The entire sequence, from receiving firing data to launching the round, took approximately 4 seconds for a well-trained crew. Multiply that by 60 seconds, account for the time needed to make sight corrections between rounds, and you arrive at 15 rounds per minute. Sustained. An American crew firing the M1 followed a different rhythm. The sequence began the same way with firing data from the squad leader, but the execution diverged immediately. American crews made coarser sight adjustments. The M4 collimator sight used by the M1 was simpler than the German panoramic sight. It provided adequate accuracy for area targets without the fine adjustment capability that German crews relied upon. This was by design. American doctrine did not require the precision that German doctrine demanded. The trade-off was speed. American ammunition handling was streamlined for rapid fire. M1 mortar rounds came in two main variants for high-explosive missions. The M43, a one-light round, weighed 7.05 pounds, with a 1.22 pound high-explosive filling. The M45 heavy round weighed 15.1 pounds, with a 4.48 pound explosive filling. Both used the same propellant charge system as German rounds, but American crews were trained to preset charges before combat. Ammunition bearers prepared rounds in advance, adjusting charges based on the expected range for that fire mission. This eliminated the charge adjustment step during actual firing. The loading sequence became mechanical. The assistant gunner stood to the right of the mortar, facing the barrel. He held the round vertically, fins pointing down. On the gunner's signal, he dropped it into the tube. The fixed firing pin ignited the propellant instantly. While that round was in flight, the next round was already in the assistant gunner's hands. The ammunition bearers worked in a chain, passing rounds forward in continuous rhythm. One round every 3.3 seconds, 18 per minute. Hour after hour if ammunition supply permitted. The American system sacrificed individual round precision for sustained volume. German observers who survived American mortar bombardments reported a different character to American fire compared to their own mortars. German fire came in carefully spaced rounds, each seemingly aimed at specific points. American fire came in continuous waves, saturating areas rather than striking points. The psychological effect was different too. German mortar fire felt like a skilled opponent trying to kill you specifically. American mortar fire felt like an industrial process trying to obliterate the entire landscape you occupied. Both were terrifying, but the American approach created a sense of inevitability that precision fire could not match. The full implications revealed themselves during the fighting around Hürtgen Forest in November and December of 1944. This was where Corporal Hendricks and thousands of other American soldiers experienced German and American mortar doctrine in direct competition. The forest was a nightmare of tall trees, steep ravines, and prepared German defensive positions. Visibility was measured in yards. Artillery was often ineffective because tree bursts absorbed shrapnel. Mortars became the primary indirect fire weapon for both sides. On the morning of November 21st, units of the 28th Infantry Division were attacking German positions near the town of Schmidt. The attack bogged down in dense forest where German machine gun nests commanded the few clear approaches. American infantry companies called for mortar support. Within minutes, M1 81mm crews were firing. The fire missions lasted for extended periods, 30 minutes, 45 minutes, in some cases, over an hour of continuous fire. The American crews maintained their 18 rounds per minute through these extended missions, pausing only to allow barrels to cool or to replenish ammunition from stockpiles that logistics units kept flowing forward. German defenders experienced this fire as an unending cascade of explosions. Survivors from the 344th Volksgrenadier Division later described the American mortar bombardments as unlike anything they had experienced on the Eastern Front. Russian artillery had been heavier. Russian Katyusha rocket launchers had been more terrifying in their initial impact. But American mortars had a relentless quality. They kept coming. The fire did not stop. Positions that German troops thought were safe because they were in defilade from American artillery found themselves under continuous mortar fire that walked methodically through defensive zones. German mortar crews attempted to respond with counter-battery fire. They were skilled at this. German doctrine emphasized quick displacement after firing to avoid counterfire, and German crews were trained to calculate American mortar positions based on the trajectory of incoming rounds. But when German crews tried to suppress American mortar positions, they encountered a problem. The American mortars would not stay suppressed. A German fire mission might force an American crew to cease fire temporarily, but within minutes, sometimes seconds, the American mortars were firing again, sometimes from the same position, sometimes from a new position nearby. The issue was sustainability. German crews could achieve high rates of fire for brief periods. 20 rounds per minute was possible for a minute or two, but maintaining even 15 rounds per minute for extended periods exhausted crews and depleted ammunition. German logistics in late 1944 were strained. Ammunition had to be rationed. Fire missions were calculated based on expected effectiveness per round expended. This meant shorter bombardments, more careful targeting, and an acceptance that German mortars could not match American volume of fire. German squad leaders made decisions based on these constraints. They calculated how many rounds they could afford to fire. They chose targets carefully. They tried to achieve effects with minimal expenditure. American mortar platoon leaders made different calculations. They had access to stockpiled ammunition that seemed, to German observers, almost unlimited. Fire missions were approved based on tactical need, not ammunition scarcity. If an infantry company was pinned down and needed suppressive fire, American mortar crews provided it. For as long as necessary. As many rounds as necessary. The standard load for an American mortar platoon was 600 rounds per tube, but those loads were replenished constantly. Trucks brought ammunition forward. Ammunition bearers hauled it to gun positions. The system was designed to sustain high-volume fire, and it did. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The human cost of these doctrinal differences became clear in the lived experience of the crews themselves. German mortar teams in the Hurtgen forest were fighting with equipment that worked exactly as designed, but within a logistical system that could not support sustained operations. Lance Corporal Heinrich Böhmer, a loader with a Granatwerfer 34 crew attached to the 983rd Grenadier Regiment, kept a diary that survived the war. His entries from late November 1944 describe the daily reality of German mortar operations. November 23rd. Fired 40 rounds today supporting counterattack near Vossenack. Good shooting. We knocked out American machine gun position, but we are down to 120 rounds total. Requested resupply. Told to conserve ammunition. Americans fired for 2 hours straight. How many rounds do they have? November 26th. Moved position 3 times today. Americans locate us quickly and fire back immediately. Their mortars seem to have endless ammunition. We fire carefully. They fire constantly. Weber says, "We are fighting the American economy, not American soldiers." These were not the observations of defeated men or poor soldiers. Böhmer's crew was experienced, having fought in Russia before transfer to the Western Front. They knew their weapon. They executed their doctrine correctly, but they were discovering that correct execution of doctrine designed for resource-limited warfare could not compete with an opponent whose doctrine assumed resource abundance. The physical toll on crews revealed another dimension of the rate of fire difference. Firing 18 rounds per minute for extended periods was exhausting work. American mortar crews rotated positions within the squad to manage fatigue. The gunner would fire for 15 minutes, then switch with the assistant gunner. Ammunition bearers would spell each other on carrying duties. The 7-man crew size allowed for this rotation while maintaining fire. German crews with 3 to 5 men had less flexibility. Everyone had to work continuously during fire missions. There was no one to rotate with. Fatigue accumulated. A German crew that had fired 100 rounds in a sustained mission was physically spent. Their next fire mission would be slower, less accurate. American crews that had fired 100 rounds in the same period could maintain their rhythm because the workload was distributed across more personnel. The industrial logic extended to crew casualties. When an American mortar squad took casualties, the platoon could redistribute personnel to maintain gun crews at effective strength. The larger crew size meant that losing 1 or 2 men did not necessarily eliminate a gun from action. German crews with smaller numbers had less redundancy. Casualties directly reduced combat effectiveness. By December, American infantry companies had developed tactics that exploited American mortar advantages. When attacking prepared German positions, infantry would call for sustained mortar fire to keep German defenders suppressed. Not brief preparatory bombardments, continuous fire that lasted as long as the infantry needed to close with the objective. German defenders learned that when American mortars started firing, the fire would continue. This created a psychological pressure that brief, intense bombardments could not match. You knew the fire would stop eventually if it was intense, but fire that was moderate in intensity and unlimited in duration created a different calculation. How long could you stay in position under continuous bombardment? How long before your position took a direct hit? How long before your nerves broke? German after-action reports from the Hürtgen Forest period noted this factor repeatedly. American infantry attacks were not tactically sophisticated, the reports noted, but they were supported by overwhelming firepower that could be sustained indefinitely. The solution, German commanders wrote, was to counterattack before American forces could establish their logistical support. But by late 1944, German forces rarely had the combat power to execute such counterattacks successfully. The Allied advance through Germany in early 1945 provided the final proof of what sustained fire superiority meant in practical terms. As American forces pushed beyond the Ruhr River in February and crossed the Rhine in March, German defensive positions faced a consistent pattern. American infantry attacks were preceded and supported by mortar fire that German defenders could not match in duration or volume. The mathematical reality was stark and unforgiving. Consider a typical engagement during the Rhineland campaign. An American infantry battalion attacking a defended German town would have 6 M1 81mm mortars in its heavy weapons company. Each mortar could sustain 18 rounds per minute. Over a 30-minute preparatory bombardment, those 6 mortars would fire 3,240 rounds. The German defenders, if they had a full-strength mortar platoon with 6 Granatwerfer 34 tubes, could fire at 15 rounds per minute. Over the same 30 minutes, they would fire 2,700 rounds, assuming they had that much ammunition available, which by early 1945 they usually did not. The 540-round difference over 30 minutes does not seem overwhelming until you calculate the explosive weight. American M43, a 1 light rounds carried 1.22 pounds of high explosive. M45 heavy rounds carried 4.48 pounds. Even using the lighter rounds exclusively, those extra 540 American rounds delivered an additional 659 pounds of explosive onto German positions compared to what German mortars could deliver in response. But the disparity was actually much larger because German ammunition shortages meant that theoretical rates of fire meant nothing when rounds simply were not available. German defensive positions in early 1945 were often rationed to as few as 20 rounds per mortar per day. American mortars faced no such restrictions. A single American fire mission could expend more ammunition than a German crew had available for an entire day of operations. The cumulative effect over weeks of continuous operations was devastating. German defenders learned that calling for mortar support meant getting brief fire missions that stopped after a few dozen rounds. American infantry knew that their mortar support would last as long as the tactical situation required. Corporal Hendricks survived the war. He returned to Ohio in late 1945 and worked at a steel mill for 37 years. In a 1982 interview with a local veterans organization, he was asked what weapon had been most important to American infantry in Europe. He did not say the M1 Garand rifle, though he respected it. He did not say the Sherman tank, though he was grateful for armor support. He said the 81mm mortar. When pressed to explain, he described the psychological security of knowing that when his unit called for mortar fire, it would come, and it would keep coming. The Germans had good mortars, he said. Good crews. But they'd fire for a few minutes and then stop. Our mortars fired until the job was done. That difference kept a lot of us alive. Heinrich Böhmer, the German lance corporal who kept the diary, was captured in the Ruhr pocket in April 1945. His diary was confiscated during processing and eventually made its way to the U.S. Army Military History Institute. Böhmer survived captivity and returned to Germany in 1947. In later years, he corresponded with American veterans organizations, In one letter from 1969, he wrote about the Hurtgen Forest fighting. He expressed respect for American soldiers, but noted that the decisive factor had not been individual fighting quality. "You had more of everything," he wrote. "More ammunition, more food, more replacements, more fuel. We were good soldiers with good training, but we were fighting an economy that could produce faster than we could destroy." The mortar rate of fire differential was not an isolated phenomenon. It was symptomatic of a fundamental difference between American and German approaches to industrial warfare by the final years of World War II. This difference extended far beyond mortars to every aspect of military operations, but mortars provide perhaps the clearest illustration because the weapons themselves were so similar. When the hardware is nearly identical but performance differs significantly, the explanation must lie in training, doctrine, logistics, and industrial capacity. American military doctrine by 1944 had fully embraced what historians would later call the firepower attrition approach. This doctrine assumed that American forces would have material superiority and should leverage that superiority through sustained application of firepower. Training emphasized maintaining continuous pressure. Logistics systems were designed to deliver ammunition in quantities that enabled sustained high-volume fire. Tactical planning incorporated the assumption that supplies would be available when needed. This was not wasteful or unsophisticated. It was the rational application of American industrial advantages to the problem of defeating German military forces. German doctrine, even in 1944, still retained elements of the quality over quantity philosophy that had characterized Wehrmacht training in the 1930s. German mortar crews were trained to achieve effects with minimal ammunition expenditure because that training had been developed when Germany was rebuilding its military, under resource constraints. The doctrine worked well in the early war years, when German operational mobility allowed forces to achieve decisive results before resource limitations became critical. But in sustained attritional warfare against opponents with superior logistics, the doctrine's limitations became fatal weaknesses. The production numbers tell the broader story. The United States produced approximately 140,000 M181mm mortars during World War II. Germany produced approximately 70,000 Granatwerfer, 34 mortars from 1934 through 1945. The ratio was roughly 2-to-1 in America's favor, significant but not overwhelming. But ammunition production showed the true disparity. The United States produced over 75 million rounds of 81mm mortar ammunition during the war. German 80cm mortar ammunition production is harder to document, precisely due to record destruction, but estimates range from 15 to 20 million rounds over the entire war period. The ratio was at minimum 4-to-1, possibly 5-to-1. This meant that an American mortar not only could fire faster than a German mortar, it would have ammunition available to sustain that higher rate of fire. The German mortar might be capable of matching American rates briefly, but German logistics could not support sustained high-volume fire. The combination of slightly higher sustainable rate of fire and vastly superior ammunition availability created a compound advantage. American mortars could deliver more rounds per minute and sustain that delivery for longer periods. German positions faced more total explosive weight delivered over longer bombardment durations. The tactical effects accumulated into operational advantages. Infantry attacks supported by sustained mortar fire had higher success rates. Higher success rates meant fewer casualties per objective captured. Fewer casualties meant units remained combat effective longer. Combat effective. Units could maintain operational tempo. Operational tempo prevented German forces from establishing stable defensive lines. The absence of stable defensive lines prevented Germany from prolonging the war, each element connected to the next in a chain of causation that extended from the individual. Mortar crews' loading rhythm to the strategic outcome of the Western European campaign. The mortar differential was not decisive by itself. No single weapons system determined the war's outcome, but it was representative of systematic American advantages that, aggregated across all weapons systems and all logistical categories, made German defeat inevitable once American industrial production reached full mobilization. The story of mortar rates of fire is ultimately a story about sustainability, that unglamorous but decisive factor in industrial warfare. It lacks the drama of tank battles or the heroism of infantry assaults. It involves mundane calculations about rounds per minute, ammunition stockpiles, and logistical throughput. But for the men who fought with and against these weapons, sustainability was the difference between survival and death, victory and defeat, hope and despair. The soldiers learned what their generals and their nation's industrial planners already knew. Modern warfare between industrialized powers would be decided not by the quality of individual weapons or the skill of individual soldiers, but by the capacity to sustain combat operations over time. Corporal Hendricks, in his foxhole east of Metz on that November morning in 1944, heard both kinds of mortars. The German rounds coming in at 15 per minute, methodical and precise. The American rounds going out at 18 per minute, slightly faster and backed by seemingly unlimited ammunition. 3 rounds per minute difference. In the moment, it seemed small. Over 30 minutes, it accumulated to 90 additional American rounds. Over hours of combat, it became hundreds of additional rounds. Over weeks of campaigning, it became thousands. Over months, it became the weight of fire that German forces could not match and could not endure. The German mortar crews were not inferior soldiers. They were trained to a high standard. Their weapon was well designed. Their tactical doctrine reflected sound military thinking developed through decades of professional study. But they were serving a nation whose industrial base could not support the kind of warfare that had developed by 1944. Germany's economy, strained by years of war, bombed by Allied air forces, and cut off from resources by naval blockade, could not produce ammunition at rates that matched consumption in sustained combat. German soldiers fought with skill and courage, but they fought with increasingly empty magazines, dwindling stockpiles, and the knowledge that every round fired was a round that might not be replaced. American forces fought with different knowledge. They knew that ammunition would be available. They knew that supply trucks would arrive. They knew that their industrial base was producing faster than they could expend. This knowledge shaped tactics, influenced morale, and ultimately contributed to victory. The broader lesson extends beyond World War II. In any sustained conflict between industrial powers, the side that can maintain pressure longest holds a decisive advantage. Maximum capability matters less than sustainable capability. A weapon that can fire 30 rounds per minute for 2 minutes is less valuable than a weapon that can fire 18 rounds per minute for 2 hours. A force that can execute brilliant operations for brief periods is less effective than a force that can execute competent operations continuously. The men who fired those mortars understood this at a visceral level. They experienced it in the rhythm of loading and firing, in the accumulation of empty ammunition boxes, in the sound of enemy fire that stopped while their own fire continued. They learned that in modern war, persistence matters more than perfection. The Wehrmacht had sought perfection. The U.S. Army had built for persistence. History recorded which approach prevailed. On that November morning in 1944, Corporal Hendricks counted the seconds between German mortar salvos and listened to the continuous rhythm of American mortars firing behind him. He did not know the production statistics or the logistical tables. He did not need to. He could hear the truth in the sound of the guns. The side that could keep firing would be the side that kept advancing. Everything else was commentary on that fundamental reality. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.